So one of the things we see as a result of intermolecular forces are two, lost my words. We'll start the sentence the other way. Surface tension and viscosity are the result of intermolecular forces. So what's surface tension? Have you ever seen this done or done it yourself? You can float a paperclip on the surface of water. Should a paperclip float? No. Paperclip's made out of metal. Metal's more dense than water. It should sink, right? And it's not shaped like a boat. So it should sink, and yet it doesn't. Maybe you've been down by the river and seen water skaters. Those little insects, and they skate along on the top of the water. And how do they do that? Well, it's surface tension. If you look at this picture very closely, you can see that it dents the water a little bit, almost like there's a thin sheet or a skin over the water, and you put the paper clip on there and it kind of pushes it down a little bit. And that's the surface tension. Other things like alcohol or gasoline, which are liquids, will not hold up a paper clip because they don't have as strong surface tension as the water does. So how does surface tension work? Here's an illustration of particles in a liquid. And so here we have a particle in the interior of the liquid, and it is interacting with all of the molecules that are near it. And here we're just looking at a two-dimensional cross-section. It would also be interacting with the ones coming out and going behind. So that has interactions in all directions. And so this one's being pulled over to this one because these are forces of attraction. And it's being pulled that way and this way and this way, and it's just being pulled in all directions. Just how I feel much of the time. Children and students and And then here on the edge, the molecules at the surface are not being pulled on this side because they're on the edge of the water or the liquid. They're being pulled and interacting with the molecules, with other surface molecules, and with ones in the interior. And so they experience a net downward force, and that is the surface tension of the water. And it resists penetration. So this force that's holding them together doesn't want you to stick things through it. Of course, you want to stick your finger in water, it can't oppose that. But a small force like a paper clip or a needle that doesn't weigh very much can float, can sit on top of that kind of a skin that the water forms on top. And this is the reason that water drops are spherical. This is a picture taken in the space shuttle. That's a really big drop of water. And it forms a sphere. And water forms a sphere because all the particles are being pulled to the inside, and it wants to reduce its surface area. And if you remember anything about the geometric shapes that you studied at some point in your education, I know you did because my children have done it recently. You've got spheres and cubes and prisms and all these different shapes. A sphere is the one that has the smallest surface area for its volume. A square has more surface area per volume than a sphere does. And so the water is going to form a shape that's going to minimize the surface area. And it forms this skin. Here on Earth, where we have gravity, when we see a water droplet, it's often this more of a teardrop shape because gravity is pulling down on it. But why does it hang there at all? It's the surface tension. And water droplets tend to be about the same size. You can't make really big water droplets on Earth where there's gravity. You can do that in space. You can't make little teeny tiny water droplets. And the size of the water droplet has to do with the amount of surface tension that it has. Viscosity is another thing that is a result of intermolecular forces. Viscosity is the resistance of a liquid to flow. In everyday life, the place you've probably heard this is in commercials about motor oil. Okay, we talk about viscosity breakdown. You want your motor oil to be thick enough that it coats the parts on the inside of your engine that it's supposed to coat. If it's too liquidy, if it loses its viscosity, then it just falls down to the bottom of whatever part of the engine it's in and it doesn't lubricate like it should. And so viscosity breakdown is a bad thing for motor oil. Viscosity is the resistance of a liquid to flow. Or you might think of it as the liquid being thick, right? So some liquids are more viscous and they would flow or pour more slowly than other liquids. So motor oil is more viscous than something like gasoline. Honey is more viscous than water. You get the thing of honey and you try to pour the honey out and you got to wait for it, right? It's just, you watch it and it slowly pours. Water doesn't do that. Water pours much faster. Something like gasoline or alcohol will pour even faster, although the difference is not as great, so you might not notice it. But viscosity arises because of the intermolecular forces. If a liquid like honey has strong intermolecular forces, then the particles can still move relative to each other because it is a liquid, but they're kind of sticky to each other. They're more stuck on each other than something like water that is less viscous. And so they can move, but they're going to move relative to each other in a slower way. And so that hinders the flow of the liquid. Intermolecular forces are a little bit like Velcro. And if you imagine that you were in a small space with a bunch of people and you all had Velcro suits on, and you're trying to move around, and the Velcro keeps catching on the other people. And so it's hard to move around. As opposed to maybe you've got Teflon suits on and it's all slippery and you can just slide right past other people. So when the intermolecular forces are strong, the molecules are kind of sticky to each other. One book I used called it stick-togetherness. And so the molecules tend to stick to each other. So if they're sticky, then it's not going to flow very well, and the viscosity will be greater. So here's a picture. Maple syrup being poured on pancakes. And hopefully all of you had breakfast so that you're not too hungry right now. But it pours slowly. Water won't do that. The molecules are interacting with each other very strongly, and so they can't pass next to each other easily. They do pass, but not easily. Any questions about viscosity or surface tension?